Hey, welcome to CodeJug, everybody. My name is Chris Judd. I'm the leader of CodeJug, and this is a special event because we have Garrett and Ivar coming to us from Europe. They're both Java champions, so we're really lucky to have them. We're going to have two different presentations. One is going to be about Java vulnerabilities, and the other one is going to be related to migrating from Spring 2 to Spring 3 and how it relates to Java EE. So we have a lot of content to get through, so I'm going to just turn it over to Garrett and
let's get started. All right. First of all, enjoy your food.
Oh, one other thing, real quick. This is being recorded, just FYI, and I want to thank Azul and Manifest Solutions for providing dinner.
Thank you. Okay, so first of all, thanks for showing up. I did a Jakarta last year in the US, and that was really disappointing. So, Houston Jacket one attended when I was there. So it's really good to see people meeting again, which is great. So yeah, this session is about vulnerabilities. The name and all the graphics are unrelated. So I probably, if I look around, all of you are a little bit older, so you probably remember this 5 versus 5 thing. My name is. If the thing works, then I can tell you. Let me see. And do it like this. Oh, wait. Now it works. Okay, my name is Gerhard Kuhmann. I'm working for Azul as a senior developer advocate. I'm doing Java since, I don't know, 2000, I think. And do also other stuff like Swift and C. And but Java is really the thing that I like most. Also did a lot of JavaFX stuff in the past, but now not anymore. Unfortunately, is someone doing JavaFX here? No, yeah, that's what I expected. No problem. So I'm a developer, and I'm not a security expert, right? So to make that clear. But on the 24th of November, 2021, we all know what happened. So Log4Shell happened. So who was involved in that one? One of you? Ah, cool. Or not cool. So that made me think, because I'm a guy more from the 20th century. So and the software landscape in the 20th century was totally different, right? So we had code that was self-written and closed source most of the time. So it was managed in some kind of repositories or folders on local servers instead of repositories somewhere in the web. Manually built, it was delivered on hardware like USB sticks or CD-ROMs, and it ran on closed networks or local servers. Large monolithic systems and connected systems only in governments and energy providers and stuff like that. So, and we had the full control of the source code at that time, which is the most important part. And the vulnerabilities at that time also have been totally different from today's. So it was more or less password hacking or cracking. So people looking into trash bins and figuring out some nodes where maybe a password might be on it and stuff like that. And then computer viruses just started to come up, and they were spread via floppy disk and USB sticks and stuff like that. So it was the early days of hacking via the internet, right? But time flies, and now it's the 21st century. To be honest, I never really was interested in security. So because as a developer, why should I? Right? So I just write my code, and there are other guys that take care about security. So things changed a lot. So first of all, we have a lot of open source software that is used everywhere. I guess when I ask who's using open source in their projects, so probably all of you will use it at some point. Then we have distributed source code management systems and automatic build systems like CI/CD systems, and the whole stuff is hosted in artifact repository where you can download it. It's running on public networks. You can access them via browsers or APIs, and everything's connected these days. And the important part is you don't have full control on the source code anymore. That's the big difference, right? So now these days, you just load some dependencies and trust them. It will work. That's what you hope. And there's a complete software supply chain in the meantime. And also the vulnerabilities changed a lot. So for example, one of the most dangerous things these days is social engineering, like SIM swapping. I just read something about that lately, which is really crazy. because we have this two-factor authentication, and the main part of that is your phone these days. But there are ways to hack your phone and to take over your telephone. And suddenly, people can do really crazy things. And they do that by really figuring out on social networks everything about you, and then calling your telephone company and then try to convince them to change the number and give it to you. When that works, I was really surprised that really this is a thing, but this is a thing. So that's quite dangerous. So we have malware and ransomware everywhere. So it spreads via emails, websites, or even short messages on your phone. Right? So you get a message, and oh, something's wrong with this one. Just click the link, and bam, you're somehow infected. Everything that is connected will be hacked. That's more or less a law these days. And spreading malicious code is way easier than it was ever before. So the whole software supply chain is a target of attacks. But to get to the rest, we first have to take a look at some definitions, because that was the biggest problem for me when I looked into that for the Log4Shell stuff. It's all these acronyms. I mean, you in the US, you guys are really great in doing all the acronyms. But for us, it's terrible, because if you're in meetings and people just talk in these kinds of things, like, what? So then the first one I stumbled upon was this CWE, so it's Common Weakness Enumeration, which is a community developed list of software and hardware weakness types. And you can find it here under cwemaker.org. They have a list, and sometimes vulnerabilities have a specific CWE code, and you can look it up there. And that's the first thing. It's not that well known. Then there's NVD, which is the National Vulnerability Database. And that thing is from the US government. It's a repository of standard-based vulnerability management data represented using the Security Content Automation Protocol, or SCAP. This database contains a list of all the vulnerabilities that have been found over the recent years and today. And you can find it here under nvd.nist.org. Right? And there's a lot of stuff there. And the next thing is the probably most important part, which is the CVE, Common Vulnerability and Exposure. These days, most of the people know that, but when I heard that the first time, it was like, CVE, not of that. So the CVE program mission is to identify, define, and catalog publicly disclosed cybersecurity vulnerabilities. That's the mission. And you can find them under cve.org. And it's interesting because they also have an API. So you can get a key which is free, and then you can ask the API all kinds of stuff, which is quite interesting.
Is this part of the government, like the second one, or not? Or they're not related?
This is the CVEs are in the NVD. That's
okay. How about the first community? That's totally open source kind of thing, right?
The CWE, yeah.
CWE is basically totally open.
Yeah, that's a community-based thing. Yeah, nice. And this is all government-based.
Okay. Nice.
And so Log4Shell is how we know it, but the CVE for that is CVE 2021-44228. This is the CVE, and at the point when it came out, and you read that a lot, and I had no idea what it means. So you can look that up in the CVE, and it gives you all this text. You don't have to read through. So this is the CVE, the text in the NVD database for the Log4Shell CVE. So and it tells you the versions that are affected by that. And then it tells you the vulnerability. So what happens if the vulnerability attacks you. And then also the description how the whole thing works. And you will find that for all the CVEs that are in the NVD database, which is quite interesting. And as I mentioned, you can access it via an API. And now that you have the CVEs in the NVD database, you also need some kind of a way to make sure how to sort them, right? What is a really critical thing and what is not a critical thing? And this is the CVSS, the Common Vulnerability Severity Score. And to make it even more complex, there's not only one, but there are two. And the first one was the CVSS 2.0. And it came with 3 severities, low, medium, and high. And the scoring was from 0 to 3.9. And you already see that this is a little bit of strange. That means even if there's no vulnerability, the severity is low. And up to 3.9, it's low. So this is a little bit strange. And you can find that also in the NVD, the whole the description of the CVSS. And then they changed it because they figured out this is not enough. We need more. So they created none, which is just if there is no vulnerability, then there is no vulnerability. And then they also added critical. Before that, it was just 7.0 to 10, and now it's 9 to 10 is critical. So you will find, if you have a CVE, you will find, most of the times you will find both scores, CVSS 2.0 and 3.1. So the newer ones always have 3.1, but the older ones have only the 2.0. So you have to look up both of them and know what it means. And that's how they compare for the log4shell issue. So the 2.0 was 9.3, which is high, and then we had the 10, which is critical for the 3.1 version. So this, and if you look it up here on that link, you will see that they list both. So the 2.0 standard is still in use, and I think most common these days. Okay, so this is CVSS, and now the big question is, now this is all the definitions that you need to know when it comes to security stuff, because this is the things that will be put out in blogs on web pages, even in the news. They talk about the CVE stuff. Yeah.
On the CVE stuff, though, if you are an organization, isn't it also important to apply a internal rating on something? Because if you have other mitigating factors, yeah, if it was out on a, out there someplace, maybe a non, but internally, maybe it's only a 3 or 4.
It depends. Yes, sure. I mean, if you're, let's say you have some closed environment, then you probably are not affected at all, because if nobody can attack you, right? So then it might not be critical. But this is just the public available scoring, and it's based on some kind of factors, how strong they can really attack you with these things. Of course, you can do something internally. Nobody holds you back from that. It's up to you. And we can look at it later on that when we have some tools, and then can get into that a little bit more. So the question is Java secure? Because that question came up to me when I saw that. And there is a so-called OpenJDK vulnerability group. And that is a group of people it's a private forum of trusted members from the OpenJDK community. And you can't just go there and say, oh, I would like to be part of it. So they choose who should be part of it. Right? So it's really like it's like this friends thing. Oh, I know you for 10 years. Okay, I trust you. So you can also be part of the group. But from the outside, you can't barely get into it just because you would like to. Right? So they receive and review reports of vulnerabilities. That means if you stumble upon a vulnerability, you can file that at the vulnerability group, and then they will take care about it. So they collaborate on fixing these issues, but they don't fix the issues themselves. So these are not the people who fix the stuff. It's really just to collaborate on making sure that they will get fixed and all that. And they also coordinate the release of such fixes. So you probably know, if you get an update, there's always now this CVE list. So CVEs that are fixed in the JDK update, for example. This is also done by this group. And they maintain the list of CVEs. That's exactly what I was talking about for each release. And it's also tracked by component. So it means the JDK is modular, more or less, right? So that means there are parts where only, for example, a specific CVE can attack only a certain part of the JDK. And this is mentioned then, because not every user uses every part of the JDK. So that means you can use Java even if it's vulnerable, but you don't use that particular part, so you're safe. So this is also stuff. That's the reason why they do it by component. And you can find that in the listing of the JDK updates. You will find the components that are affected by the CVEs. And they discuss all of JDK security issues, and they also do not actively test the stuff. This is not done by this group. So there are other institutions that do that. And that leads me to the Java release cycle. And you might wonder why this is important here, but you probably all know the old one, right? When we came from JDK 6, which was more or less the first one that was open source. And then it took 4.5 years to get to JDK 7, and then it took another 3 years to get to JDK 8, which was the first long-term support version, or LTS. And then when we look at the new cycle, which is, you see, it's every 6 months we have now a release, and the black ones are the long-term support versions. And they change from 3 years between the long-term support versions to 2 years. Right? And now you might ask yourself, okay, but why is that important? There's a simple reason. This was more or less the old release cadence. And that was the number of features in each release. So that means JDK 8 was 56, and then JDK 9 was 91 features. And the reason was because it became modular. And then when the new cadence came out, this had been the number of features per version. You can imagine that if you put less features in a release, then you reduce the vulnerabilities per release, the potential vulnerabilities here. And that's the reason why this is important to know. So if you just have 12 new features, it's way more easy to test them and to make sure that this stuff is secure instead of having 91 and you have to make sure that everything is secure, right? So this is, and you see, it's even going down like 5, 7, which is way better for the security stuff. And then there's also Java updates. And who's updating is JDK regularly here? I would like to see some fingers because that's really a problem. There's this CPU updates called critical patch updates. Does someone know that? Nobody. That's interesting. The CPU updates, they contain only fixes for vulnerabilities and for critical issues. And that's it. Nothing more. And then there's so-called PSU updates. Did someone hear about that one? This is the stuff that all of you download. If you download JDK updates, this is the PSU. Patch set update. This is available from all the vendors. If you use Tamarin or whatever you use, they all provide these ones. So the difference is the PSU is a superset of the CPU. So it contains the CPU, and then they also add fixes for non-critical issues, and they introduce new features to that. So this is a potential risk for new vulnerabilities, right? Nobody knows that because most of the people don't use CPU updates. The reason for that is the CPU updates are not for free. They are only available from Oracle and from Azure and from Bedsoft. No other vendor provides these updates. And it's a lot of work to create them because you have to do a separate run that only does the vulnerability fixes and no new features and no non-critical issues. And how it works, it's a little bit strange to understand because it's like that. If we have JDK 17, came out in September, and then January we had 1701. And on the top part, we see the PSU, and the PSU contains the CPU. And on the lower part, this is just the CPU update, okay? So then if we go to the next one, we get 4 times a year, we get an update. If we go to April, the PSU gets all the fixes, security fixes, and so on, and new features in the 1702. But the PSU, the CPU, sorry, it gets only the vulnerability fixes from this one, from 1701. No new features. The CPU is always 1 quarter behind the PSU. The reason is it's additional time where this one, including all the new features, could be tested. And then at that point in time, they just create the fixes for this version. And then going on. And this one always contains the new stuff. This is the stuff that you can download from the internet. This is not available for free. Yeah.
And these are only for LTS releases, right?
No, they are also the CPUs. Now we also do that for others. So because these are just updates, right? So if you have, this depends on the vendor, right? So I think Oracle does it only for the LTS ones. We also do that for the in-between ones if they pay for it. So this is not a big deal to do that. But yeah, it's hard to imagine what it takes to create this. All these packages. So you just go to the website, select the architecture, the operating system, the version, download. If you would like to create these things, then you need to make sure that you run the test. First of all, we have to TCK test everything. And that means you also need a sound card in your computer. You need a printer, you need a CD-ROM, a DVD drive, and all these things. Everything that can be run by Java need to be tested for all different operating systems, all architectures, and so on. And that takes a lot of time, and that's the reason why this is an additional work. This is the reason why you have to pay for it. This is one of the reasons why Java is not always for free. And then it goes on. This is the same thing for all of that. Okay, so everybody understand that because this is sometimes really crazy when people talk about updates. For example, if you go to the Tamarin website, the Adoptium page, they say it contains the critical patch updates. Yes, of course it does, but it also has the additional stuff. because it's a PSU, it's not a CPU update. So, and the CPUs you won't find. In the old times, you found them on the Oracle website when Java 8 was free. You maybe remember there was something like 8U252 and 8U251. That was the two versions.
So what the CPU with PSU thing, which Java version did it start? From Java, 8? I
8.
don't remember this one.
Yeah, 8 had it. So, and I have an example that relates to 8. So it's when the PSU 8252 came out, it had a problem because it prevented Hadoop cluster and Solr from running. So when you updated your machine with this update with the PSU, it didn't work anymore. But when you use the CPU 251, which was the CPU update, which only contained the security fixes for the last PSU, right? Then it worked because the problem was really new features that had been introduced in the PSU, and that led to the problem. So there is a reason why CPUs make sense. Especially if you run mission critical stuff, it makes sense to go on CPU. But this is not everybody likes the paper Java. So, but this was one example. Okay. So then this is just if you use not a CPU but a PSU update, then this is a risk. The other one is if you don't update your JDK. I did that for a long time. I just downloaded, for example, JDK 11 and stick to it. There's a new update. I don't care. Well, once I figured that out, I update every time there's a new JDK. Because let's say you download JDK 11 GA, and then after some time, there have been 6 CVEs. This is the true numbers for 11. And then there came out 1101, 2, 3, 4, 5, and they fixed one, and the 5 have been still in until 1105. They haven't been fixed. It wasn't minor stuff. And then 1106 got a fix, and then there was nothing until 1111 that got another CVE. So CVE means there was a vulnerability in that JDK. And then in 11.012, there came 10 new CVEs just for this one. So, and then after that, nothing anymore. But that means if you stick to 11.0, you have 17 vulnerabilities in your JDK, right? And you better update to a newer version because that could be critical stuff. And this is what people probably most of the times don't know. You can look up all these things in the NVD. So that's for all JDKs, you can figure out how many CVEs are in there, are they critical or not, what is the impact. So update the JDK. Instead of saying, if it ain't broke, don't fix it, I would say, if it ain't broke, at least keep it up to date. So this is my advice in this case. And it doesn't hurt. Okay, another thing that you can do to avoid problems is modular runtime images. There's one thing called JLink. Does someone use that in the room? Who's using a JDK in production? Nobody? Who's using a JRE in production? What are you using in production? .NET developer. Wrong duck. It's the duck. The .NET user group. Yeah, so it's like if you use so the JDK contains all the Java stuff plus Java C compiler, Java doc, and other things that you need for development, right? Way bigger. Don't use it in production because you don't need it, right? So JRE was the reduced version without the Java C compiler, without the Java doc. It's just made for running something in production. JLink is like JRE on steroids because this one can reduce, because now we have a modular JDK, it can reduce the number of used modules to the stuff that you really need in your application, right? And why does it make sense for security reasons? Well, JLink makes that possible, first of all. And removing unused modules, it also reduces the risk of getting hacked, right? So because what's not there cannot be hacked. That's the point. So you should really use JLink. It isn't that hard. You have to look into it once, and then you can really, there's a tool called JDEPS, I think. This figures out all the modules that your application needs. And you can then pass this information to create a JLink runtime for your application only. Pretty simple. So let's take a look at the software supply chain, because this is really complex these days. So it starts with us, the developers, and usually we get the stuff from some, yes.
Will J-Link work for JDK 8?
No, because this is modular, it's only from JDK 9.
So what percentage of, if you know, projects are still using JDK 8?
Oh, it's quite a lot still.
Like,
So, I mean, we can ask in the room. So who is using JDK 6 or 7? Someone? Because I know people out there. So JDK 8. See. JDK 11. 17. Maybe someone already on 21. Tomorrow is the big day. Yeah, so we drag the stuff usually from central repository. Yes.
Another advantage of using J-Link is if you're especially shipping containers, it reduces the amount of space required for that container as well.
Yeah. So it really makes sense to use it. But it's interesting. I always ask that when I do the session, and literally nobody's using J-Link. So even when I do it at big conferences, people don't use it. I don't know why.
They're still on it.
Yeah.
Well, what's an example of a size difference, right? Is the expectation for a normal Spring application?
Oh, that's hard to tell because it really depends on your application. So, but it's in the megabytes, so it can really be small depending on if you, for example, you use microservices in a containerized environment. So that means you would like to keep it as small as possible. And if you do it right, the services are not huge, right? They are small. That means they just use a little amount of these modules. So that could be a really small runtime image because it only contains the stuff that you need. So that's the big advantage of the whole modularization. Otherwise, why would you do that, right? Otherwise, it's just overhead with all the modules. But this is the reason why they did it. You can really create smaller runtimes tailored for your application.
Does it play nice with reflection stuff, or is that sort of?
Yeah, I mean, it contains all the, this is the JDEPS tool. This figures out all the stuff. You can run, I think, on your jar. Let's say you have a fat jar from your application. You can run the JDEPS on this jar, and it will figure out all the dependencies, and then it will tell you the modules that you use, and then you can just create the building stuff on that. So it should work. So I just have good experience with that.
I can look up the exact numbers because I have them in the presentation.
Oh,
So I can get to you before the end of the day.
Yeah, I never really thought about, because it really depends. It would be good to have one application and just have it side by side, one with the JRE and one with maybe JDK JRE and the JLink one, and then you can compare the sides.
At least you can remove the swing stuff from your Spring Boot application.
Yeah, Swing AWT and all these things, right? Yes.
Is Graal VM an alternative to J-Link?
Yes.
No, this is a totally different thing.
Okay.
The Graal VM is, you have to think about it like this. So Graal VM replace the compiler, the C2 compiler, by a version that is written in Java. That was mainly for maintainability because C2 is in C, it's quite old, it's hard to maintain. That was the intention. Then they came up with the AOT compiler. So what they do is they run the application in the enterprise version. They run the application in the Java C2 compiler, compile it once, run it, create a profile. Then you take the profile and compile your application, including your profile, the data from the profile, into a native image. This is native code. It's no Java code anymore.
That part I understand. I think I should have said my question better. From the security exposure standpoint.
Yeah, of course.
Because
yes.
it's reducing your
Yes.
exposure.
And this is even different because it's native code, so it doesn't have the attack vectors that Java offers. But it has other problems, right? So nothing is for free.
Right.
It's just a different way. There will be people who figure out how to hack the image stuff, probably. Yeah, but yes, it is a way to reduce the security risk. Yeah, because the native image only contains the classes that will be used. That's the reason why the footprint is smaller. If you have a JDK or JRE version and you bundle it in a jar, it will always contain the whole stuff, right? So you drag in a library, you get all the classes, if you need it or not. In GraalVM, it just takes the one class that you need from the library and compiles it down to native code. This is also the problem with GraalVM, because if you use reflection, then you need to let GraalVM know all the stuff that you use, otherwise it will fail. It will compile, you can start it, at the first moment try to use reflection to use some other code, it will just crash because the code is not there. That's the problem with the native image stuff.
Does J-Link happen at the end of the build cycle, doesn't it?
No, J-Link, yes, you can do, but usually yes, because you create your job first, then you check with JDev, then you create the J-Link for this application. Yeah. So that's really what you do. You can even create a native installer for that. If you would do, for example, a desktop application, there are still included in Java. If it's Spring or JavaFX, doesn't matter. So you can create installers that have native applications, which is more wrappers. You have an exif wrapper that starts the jar file, something like that. So they have that. And then you can really bundle that with installers and install it like a normal application on Windows or Mac or Linux. So this is possible with J-Link. Yeah.
So is this J-Link available in the Docker repositories for making Docker images?
J-Link comes with the JDK. It's part of the JDK. It's a tool in the JDK. Yeah, that comes with from JDK 9 on. It's available. So you can just type it in. If you have the path set on your machine, you can just type in J-Link and JDev. It should find it. Okay. Okay, so we get the stuff from a central repository, then we ourselves submit it in our own repositories like GitLab or GitHub or whatever, and then usually it gets into some build systems or CI/CD build systems, and these again drag some stuff from the central repository. Then we create containers there, put them in an Artifactory repository, and this then sometimes goes back to the central repository, or it goes also directly to production. So this is more or less the software supply chain, and there you will find other diagrams. They sometimes have more stuff or less stuff. It depends. This is more or less the stuff we have to handle. And all these different things have come with different vulnerability options, let's say. So you can submit bad code, you can compromise the source control system, build from modified sources, compromise build platform, and so on. I don't read all this stuff, but these are all vectors that they can take to access the supply chain. And this is stuff that happens actually. Vulnerabilities in principle here are, for example, these are just examples, right? The hacker can pretend to be known contributor and submit bad code. Sounds so simply stupid, but yeah, this happens. If you're not aware, people just take over. Oh, this is just to pretend. They can even take over committer accounts and then commit malicious code into the code base. And you usually think, yeah, that sounds like in a movie. It never happens. It happens a lot. So it's strange. But I wasn't aware that this is something that people just do that because we are also lazy right now. Yes, we are secure. It's no problem. So really, you should check these things, right? You can retrieve password from build scripts. I also found that at a customer when I was a consultant. So they put just the passwords in build scripts because it's so easy. Yeah. And then if someone stumbles upon it, good luck. You can upload modified packages if they don't need to be from trusted build systems and so on. I don't read to all of that because I don't want to spend the whole evening on that. So some facts. I was looking on the web for some reports. There's the Sonatype State of the Software Chain report, and they say that over the last 3 years, the number of attacks increased by 742% on the software supply chain. So they track that down every year. And this is really huge numbers, right? So people really have this kind of stuff. This is from the NVD, from the National Vulnerability Database, where they did a distribution by severity over time. It's a little bit hard to see, but you see the increase since 2017. There was a huge bump in these vulnerabilities. And in 2021, it was 20,142 issues that have been reported in the NVD. And it's still increasing. So it's a lot of vulnerabilities going on since they track it. So this looks quite nice, but then if you see where we end up, it's really crazy. This is something, big problem, user laziness. These numbers are from March this year, when I created the session. 34% of all downloads from Log4j are still using the vulnerable version, even if it was patched 15 months before. People just download the old stuff, which is crazy if you think about it, right? Everybody knows about Log4Shell, and these guys download, I download the old version. It contains the vulnerability. I don't care. So this is really strange. Right?
Why didn't they take that off?
Well, this stuff is everywhere on the web.
Yeah, and I can help answer that. So I'm on Log4j team, and the reason why it was not taken down is because there was a concern that it would affect other things and
Yeah.
break other things
Yeah.
because there's so many dependencies.
Which makes sense. I mean, you
And
never
it's
know where
just
this stuff is
It's like you
on.
would just break the
Yeah.
internet. So there was also a talk about having like a brownout where it goes offline for maybe 60 minutes, and that was just as bad. So
Yeah.
it's out there.
Yeah, so yeah, I think it's our responsibility to really take care about it. I mean, it was known, it was patched, it was made public that it was patched, so people could get the non-vulnerable version, but they don't. So and the number shrinked a little bit. I think the latest one is around 20 something, so it's not really 34 anymore. But that was from March, and it was really shocking to read that. So because everybody was like, "Oh, look for shell, look for shell," and then you see that, and I was like, "Oh shit, this is really hard." Other stuff is, yeah, project vulnerabilities, 6 out of 9, and this is also from the Sonar type report, transitive dependencies. So you have some dependencies, you drag them in, oh, they are secure, but they drag in other stuff that you don't know, and that might be vulnerable. And this is, as you see, 6 out of 7 vulnerabilities are related to this transitive dependency. So this is really critical. Then this is from another report, this Synopsis. It's also a company, they do that. And they found in the code bases they scanned, in 84%, they found vulnerabilities, right? And 48% had been high risk vulnerabilities in their code base, which is a lot. It means 50% nearly was really highly vulnerable. And this is, if you think about it, then maybe you would like to check your code base if you use stuff like scanners, but we will come to that. Another one is open source, because open source is everywhere, and it's the same report. And they said that in 96% of all scanned code bases, there was a usage of open source, and 76% of the scanned code bases have been already open source, the whole project line. And that leads me to open source in general, which is do we have some open source committers here in the room? Yeah, good.
It's all JavaScript though, so I'm sorry.
Oh, that doesn't matter. You probably know this stuff, right? But you don't have to read through it because it contains some specific points. I will highlight them. It means is provided as is, right? Without warranty of any kind. And it says, in no event shall the authors or copyright holders be liable for any claim, damages, or other liability. Did somebody ever read that? Right? Because if you read that, then it means I owe you nothing. This is what it means. And that's okay. That's fine. Right? This is open source. Doesn't mean we come to that, right? You probably know this stuff from XKCD. So you always have to keep in mind, open source maintainers are not suppliers. Right? You don't have any business relationship with them. You don't pay them for anything. So that means if you use open source software, you have to make sure that it works and that it's secure. It's not up to them. Right? And this is what probably sometimes goes in the wrong direction, especially with the Log4j stuff. They blame the people that, oh, it's not secure. How could it happen? Well, this is not their fault. Right? So, and this is one of the biggest problems here. People, we are so used to use everything for free. Nobody would like to pay for something, and then we're blaming the guys who did that when something goes wrong. This is really a problem in the industry. So what can we do? That's the big question, right? There are several things. So there's one thing which is called shift left. Who heard about that? Yeah, probably a lot of people. If we have the software supply chain, because this is mentioned quite often, shift left, so what does it mean? So then we usually have the dev part on the left side and we have the ops part on the right side. And shift left just means that the security awareness should more go to the left side, to the developers, right? So because in the past, and I can just say, yes, this is true for me, I never really care about security because there have been other guys in the company that did that, right? So, and this is the whole shift left thing, right? So that means if we take a look at DevOps, then this became DevSecOps in the meantime, because this is now, if we have this DevOps loop, you probably know that: plan, code, build, and then release, deploy, operate, monitor, and then back to planning. This is this loop, right? So. And the left side should be the dev side and the ops on the right. And where's the security here? And security is everywhere. It's not related to one part only, right? So there's not really this shift left thing. So it should be everywhere. So what we say is shift left, yes, but also validate right. And I will come to that few slides, what it means. So first of all, you have to update your JDK. This is really important, as we saw, and you can use different tools. I think most of you will know SDK Man, probably. Yeah, that's quite a cool tool, and it supports many JDK distributions. It's command line only. It's only for Mac and Linux, and you can download and install JDKs. You can keep them up to date. That's a quite nice tool to do that. Now I have to pitch my own thing, and this is just because I was lazy. And I was really, because I had so many different JDKs on my machine, I was like, oh, there's a new update. Okay, so I have to check it. So I thought about, is there a way to figure out from the tool side that just tell me if there is an update, and then I can update it from there. So this supports all the JDK distributions that we have. That we as a community have. So there's 20 distributions in there, and also Gravium is supported. It's a taskbar application that runs, it's Java X1, so it runs on all these operating systems. And it also gives you infos about the vulnerabilities. And that's why I mentioned it here, because that could be quite useful. So it looks like this. It's just a little tool. It sticks in your menu tray. And it shows you all the stuff that you have installed. And then you see these little red lines here. And that shows you the vulnerabilities for that specific JDK. So you can click on that, it will open this, and if you click on one of the buttons, it will directly guide you. It will open the browser and will, hopefully, and then it will show you the CVE entry in the NVD database. Yeah.
So the automatically update itself, get a JDK mon version, because vulnerabilities could be later than the JDK mon release.
The JDK mon is that's unrelated to that stuff. So
what I mean to say is that the date in which the JDK mon is released, or you have it on your computer, but the vulnerability scanner that could be later than that date, right? How would it know that?
Well, it goes out on the internet. And then
yes, there is. We created an API that collects all the JDKs that are available, and that runs 24/7. And this API I use here to get the latest information, and it pings that every 3 hours. So that it will update, and it will gives you notifications on the screen that, oh, there's an update for you. And then you can click. It says, for example, you see it's DMG, TAR-GZ, or zip. You can click on it and will download the version to your download folder, and then you have to install it. It doesn't install anything. It just makes it available for you to download. That's the whole thing. And when I saw that the NVD has the API, I just applied for a key, and that's the way how I look up the vulnerabilities. So you can really check the NVD database for a specific OpenJDK build. So that means it doesn't matter if it's Zulu or Tamarin or whatever. If it's OpenJDK, it contains the vulnerability. And then you can look up the CVEs and also the score, and that's what I do here. And then you can see, oh, there's a high one. You can click on it, then you can read through it, and then you can download the new version and fetch it. So this is the idea behind it. So for me, I was just lazy. And in the meantime, it also shows you when will be the next update, when will be the next patch release, and all that. This is also shown. So it's just a little tool that I wrote, but it could be useful. Then there is static code analysis. You probably know that. It's usually part of code reviews. It identifies vulnerabilities in source code. I just click through it because I think I don't want to run out of time here. We have this different, this is just, it's not a recommendation, but on the NVD or the NIST on the government page, they just mention these. So this is, it doesn't mean that these are good or whatever, it's just a list that you can find it in some. You see some are free, some are you have to pay for, and there are some I will just go find security bugs. You probably heard about find bugs, and then this is the successor to that one. So I think Spotbugs was the successor, and then this is just a plugin for that. Yeah, this is free of charge. It extends Spotbugs, more than 400 plus bug patterns. It's a plugin, and yeah, it looks like this. It's not really. This is the Eclipse plugin, but it shows you some stuff like, oh, there's vulnerable code. You shouldn't do that, and stuff like that. It helps you in the IDE, which is quite useful. That means this happens when you code. So it's really before you go to building and all that, which is helpful because this is easy to fix. Right? This is stuff you can avoid. Then there are so-called vulnerability scanners. Who's using that? Someone here in production?
Twistlock.
Yeah, okay, there are different ones. So these things can do way more than the static code analysis. So they detect vulnerabilities. They're using either their own databases or public ones, or they probe for common flaws, so they know how to attack code, and then they try it and tell you, oh, it doesn't work, so there's a problem. They monitor also misconfigurations and other stuff. So this is quite powerful things. I don't believe all of that. They also help you. There are new packages, for example, if they figure out, oh, you have a version of a library and there's a new one, you probably would like to download that one. And so they do these kinds of things, update dependencies. So how they work usually is they can scan and fix directly the source code. They can also scan and fix and monitor the repositories that you have, and also for the build process. And they can scan the artifact repositories and even containers. In production, they can monitor, but this is usually done by an agent. So who's using scanners in production here? Someone scanning code in production or stuff? Probably no one. That's our experience.
How about contrast is best qualified for production?
Yeah, but this is not scanning in production, right? So in production means when the code is running, you probably don't check it, because you trust the CI/CD build.
Right.
And you say, yeah, I tested it in CI/CD, it's all good. But at runtime, other things can happen, right? You can scan that, but this is, like I said, this is agent-based, and this usually comes with an overhead. So how it works is, if this is the JVM, then it has these different parts, and it comes with an API, which is an instrumentation API. And then you can attach an agent from the outside to that API.
There's a tool called Contrast, which
I know. I also have that on the list. Yeah. And what it does, it adds a callback, for example, to the class loader subsystem. And every time the JVM loads a class, it triggers the callback in the agent. And then the agent knows, oh, there was a class loaded. And then this is how it goes. But this comes really with you can do fast agents, but usually they come with at least 10% CPU overhead. So that means it cuts 10% from your performance, which also means in production you have to pay 10% more, right? And that's the reason why companies usually don't do that. Okay, so we have some vulnerability scanners here, and you see we also did one, and this is a little bit different. That's the reason why I mentioned that here. And again, we have free ones and we have paid ones. And this is just an example. There are more. Black Duck is quite popular. So, for example,
the agent goes in front of your APM agent, right? So you would go in front of app and get it to that volume.
Yeah. It depends. So there are different ones. So there is one from I always forget the name of the company. I maybe later. Yeah, I just forgot it. But they go directly to the JVM and they trigger all kinds of stuff, but the overhead can be up to 30% in production, which is the reason why you don't use it in production. It really brings down the performance, and that's the bad part of it. So if we have sneak code, for example, they, for example, don't offer anything for production because it's just going with an agent, and that's too slow. We won't go there. So it's free and a paid version, 9+ languages, developer first approach. So that means it's for us. And it's a standalone version. You can also get IDE plugins, and they have CI/CD integration. So it stops at CI/CD. That's where they say this is the last prompt that we cover, and this is how it looks like. So it shows you where the problem happens and what it is. Right? This is in principle what they do, and then you can fix it. Then there's SonarQube. Probably many of you know that. Very similar. They can even do more. They have also free and paid version. They have 30+ languages, which is one of the reasons why they are so popular, because you can also cover JavaScript and all these kinds of things. It has more than 4,800 analysis rules. It's a standalone version, also plug-in, and also CI/CD integration. And the screenshot sucks, but it's in principle not important what's on there. They tell you again where does the vulnerability happen and what is it, right? So this is the things that they do, and also why. So they can even explain, oh, the problem is in that because of that. So this is in principle every time the same. If you work in the IDE, they can tell you all these things, which is good. Then I will mention our own vulnerability detection, which is a little bit different because it only covers Java. It only runs in production, so it's not for CI/CD or anything else. And yeah, like I said, it's Java only. We have fewer false positives, and I will explain why. And it does also code inventory. So that means it's in the JVM, because we do JVMs, we implemented it in the JVM itself. The JVM loads all the classes by adding an agent and ask the agent all the time and let him know. So what we do, the JVM just collects that information anyway. And from time to time, it just forwards it to a piece of code that we name forwarder, and you can implement it in your own infrastructure. And this forwarder then will talk to the internet and get information about that.
Your JVM only, or is it for all the JVMs?
This is just for the Azure Zulu JVM. And it also detects code that is not used. So that means it has all the code base, and it just logs all the stuff that it's using. And then it can tell you, you know what, in your code base, you only use that code, but this code here, you never touch. So maybe you can just get rid of it, right? Stuff like that it also offers. And it has no Java agent. So that means we don't have any performance overhead. It's below 1% because it's running in the JVM. And that's the difference here. And what it does is you get some, it doesn't have a fancy UI because it's more meant to be an add-on for other tools, because this is only for production. So what we do is we tell you, where does it happen? We say, is it vulnerable or not? So this is the scores that you saw. And then this is the big difference. We can tell you if it's used or not. And that comes to your point. Because we can tell you, yes, you have a dependency on log4j. Yes, it's the vulnerable version, but you never use it. Because we know it. Because the JVM never loads the classes. So it's, you're fine. And that's the big difference. The other tools can't do that. They can just tell you in CI/CD, they scan the jars and they tell you, oh, by the way, you use log4j. This is vulnerable. It will fail. But we can tell you if you actually really load the classes or not. And that's the big difference here. And we created it just because we saw that really companies don't check code in production. They just do it in the CI/CD systems. And so if we talk about a secure software supply chain, then we think it could look like something like this. So you have the supply chain. You use stuff like log4j and Spring, and on the other hand, use Cassandra or Kafka, which is interesting. If you talk to Kafka users and you tell them, oh, by the way, you use Java, so no, we don't really use this Kafka. No, Kafka uses Java, and they just don't know. Right? So this is also some kind of the problem. So that means in development, you can use all these code scanners like Contrast or Coverty, or for example, Snyk. And this also works for CI/CD stuff. And for containers, there's Anchor. You also have code that just scan containers, and then in production you could use the Azure just to do that. That's how it could look like to secure a supply chain. But you really should make sure that you at least have these security scanners in development and CI/CD. Right? That means shift left, right, and validate right. So because we can validate the stuff that happened in CI/CD, and we can make sure that it also works in production. This is the reason why we say shift left, yes, but also make sure in production you're in the right way. And the takeaway. You should follow an automated patch update schedule. So this is usually it should be in line with the OpenJDK vendors. Like tomorrow there's a new version. You don't have to switch to the 21 tomorrow. But there will be the next update coming soon. I think it's next month then. And then automated application packaging with JLink is one thing you can do. Watch out for CVEs and libraries. You can even check the NVD, or there are tools like scanners that can help you with that. And yeah, use vulnerability scanners. So this is really something you should, if you don't do it, do it. It helps a lot. So do you need to be a security expert? No, but you need to be aware. Right? This is the takeaway from that session, because I'm also not a security expert, but now that I know all this stuff, helps me to be aware of things that I didn't or wasn't aware of before. And so with this, I just say stay secure. And thanks for listening. And I have one more thing, because I have to mention that. So Simon Ritter, my colleague, he wrote this book, and you can get it for free. It's if you would like to migrate, for example, is someone running on Oracle here? I have to measure them. We all have Oracle, right? So this book is more or less getting out of Oracle on OpenJDK. Of course, we mentioned Azure there, but this is in general on OpenJDK. It could also be used to get on Xamarin or whatever. It's really to how get I do I get from JDK 8 to JDK 17, for example? What do I have to take care about? All these things. So you can download it if you follow the link. I think you have to sign up with your email address, just use something for spamming or I don't know. But then you get the PDF for free. You can download it and check it. And that's it. I hope I didn't run too much over time. Yeah.
It's more application level.
Why don't you switch one? You answer the question. Go ahead.
Yeah, I just want to, for those that may not want to be aware of it, OWASP, it's more application level, but really good resource as well.
Okay. Well, that's good to know. Yeah, there are lots of resources out there for security stuff.
And they have libraries.
Yeah. So my impression is that even if the stuff is out there, people just don't use it. So that's the problem. It's really we are the problem. It's not that it's not there. Yeah.
Most recent versions of IntelliJ Enterprise also now tell you, if you add a dependency with a vulnerability transient too.
They also added that, which is good that they did it. Because I mean, we are just lazy, right? So I don't want to look up the security stuff all the time.
Looks like Steve has a question.
Oh yeah. Oh,
Go ahead, Steve.
thank you. Have to put the.
Hey, Steve, you're on mute.
How do I?
Seems to be talking about.
There you go.
Just be covered up. Okay. I have two questions. First one is, all of these government databases are, I presume, U.S. government, and I'm curious how you Europeans feel about that.
Oh, we are happy that there is something. Because this is the only database that is available. And because it's publicly available, we can, like I said, I also use that for my tool, so you can really check that and use the API, which is great. So it's not really because it's US, it's somehow not usable or hidden for others. So it's really publicly available and used by everyone. I think it's the only database worldwide that's using that. So I think we are glad that there is something available.
Okay, that's good. My second question is, if you use JLink to find and eliminate runtime modules that you're not using, do you know of anyone that is providing a replacement for those that acts as a honeypot so that it can look like you're, and that could be in an early warning system?
Oh, and this is just JDK modules, right? So I think that shouldn't be a problem because it's not really your application. This is not just shrinking down your application. It really shrinks down the JDK modules to the stuff that you need. And I think that shouldn't be a problem. And you don't need some replacement if I got it right.
So it's like if you were using jar libraries, just not including the libraries is what it's basically doing.
Exactly.
So there'd be nothing to call, Steve. I don't think there'd be a real need. Plus, the module system is not flexible enough to provide an alternative.
Yeah.
You either have a dependency on that module or you don't have a dependency on that module. It's not, I can put another module in its place.
Okay.
And CVEs in general, it's not just for libraries, right? There are CVEs for things like Visual Studio. And so as you're exploring and learning about CVEs, that was something I learned, is that, I'll also update everything else in your tool chain, because there's a lot of CVEs and IDEs and everything else.
Operating systems.
Yeah.
Database.
It's everywhere. And that's the good thing about the NVD. It's not only specific to languages or programming, it's everything. It's Linux versions, it's whatever. So it's everything software.
So I just realized you're from Europe, so Europeans, IT people use the same thing as we do here.
Yeah.
Okay.
Yeah,
There's no
everything I
separate-
know is the NVD. I think there's no other database.
There is an OSVDB.
Oh yeah, that's true.
I'm sorry?
There is an OSVDB.
There's OSVDB. Who manages that?
I don't know who manages it, and it's almost all the same data.
Okay, okay, so.
So I think the NVD is the biggest one that I know. It really contains a lot. If you look in there, you get lost. So it's really not, it's also not easy if you use the API to figure out how to question it correctly so that it shows you the CVEs, because they have a quite complex key to do that. But once you get there, it works quite well. So you get really all the information you need. Yeah.
Thanks.
Yes, I will not get food and that. Talk.
I also checked in the savings for JLink. If you're just using core the base JDK is about 300 plus megabytes savings in space.
Chris, J-Link started since Java 9, and what is that, right? But CPU, PSU stuff, I haven't been doing Java. That was also around that time, or
Yes.
even before that?
Well,
Java
that was
10,
Java-
not
that was Java 8.
22, okay.
I don't know of anyone who only uses CPU. I mean, that's gonna be like banks probably, or
Okay.
trade companies, the ones that have to be 100% up all the time and
Yeah.
the least risk. But they're also the ones paying the most money to the Oracles and the Azules and all the other, whoever they're getting the JDK from.
Good, thanks.
All right. So I'm not using the latest Tamarind, I just checked. So I'm not secure, but I'm on your internet. Okay, so but we're going from the, I'm Ivar Grenstad, I'm the Jakarta developer advocate at Eclipse Foundation. And I'm happy to be here on this tour. What I'm going to talk about is migrating from Spring Boot 2 to 3, and also weave in what Jakarta has to do with it. So who's there on I'll use the Spring Boot? What's the version 2? Have we got to 3?
Version 1.4.
1.4, okay, so you're in for a treat.
Yeah.
So I'll explain why I'm doing this talk in a while. So here's my social media coordinates if you want to follow me on LinkedIn or stuff. It may be at the end of this deck a reason why you should follow me on LinkedIn. I'll get to that, but you can find me there. And if you have any questions, you can just ask me on any of those meetings. I'm also a Java champion, and yeah, work for Eclipse Foundation, lots of open source stuff there. So first of all, Jakarta, and Jakarta 10 came out September last year. It's about 1 year ago. I think it was September 21 or something. And that's the latest release of Jakarta out there. And Jakarta is all about specifications. So if you're working on Spring Boot, you know it's kind of a library, sort of a framework, something in there. What we're talking about is standards and specifications. And specifications in Jakarta, that's usually a specification document and some API artifact. That's what you know, what you do is when you develop code. And we have a TCK or test compatibility kit that we use to test that an implementation fulfills the requirements of the specification. So when we've tested that, we have a compatible implementation. And we need at least one open source compatible implementation to ratify a final specification. So it's all open source, everything is open source. That's kind of the difference from when it was Java EE, when the TCK was under a proprietary license, but now it's open source. And Jakarta 10 had a lot of updates. These are all the specifications that were updated in 10. All the blue ones were updated. And all the gray ones were stable, less errors, whereas they're not updated for this release. They may be updated later. And we have one new one, CVI Lite, which enabled us to do compiling to native with GraalVM. So you can use Jakarta with GraalVM if you want to. If you take away some of these specifications, we're left with a subset, which is called the Jakarta 10 web profile. And web profile has been with us since Java 86, so it's not a new thing. But it's kind of expanded a little bit, and this is usually what you need to create a traditional web application. It has persistence, it has transactions, security, and some UI stuff. But most of us aren't doing that kind of stuff. We're doing smaller things. We're doing microservices. And even though you usually have some sort of persistence in your microservice, we define the Jakarta core profile, and that's the first time we establish a new profile since 2006. So it's a new thing, and core profile is targeting microservices or headless services, if you like. And this is where we have the new CDI Lite specification come in. So if you're in an implementation that implements the core profile, you potentially can compile to native using VM if you want. And with Jakarta 10, we set the API source levels to 11. And that was kind of a restrictive thing, but we saw there's no reason actually to move to 17 at the point. What we made sure is that the TCK runs on 11 and 17, so that the developers, if you're using Jakarta, you probably would be on 17 and you would use a runtime run on 17. But if you're an older system, you can stay on 11 if you want it. So we support both, but usually you'll be on 17 any of the implementations. All of them they have to certify on 17, but they can't certify on 11. So then, how is this relevant to Spring? So to come to where it's relevant, we actually have to back a little bit back to Jakarta 9. And in Jakarta 9, we did this namespace change that you probably noticed when you do the migration from Spring Boot 2 to 3. And we changed a lot of packages from JavaX to Jakarta. And we didn't do a lot of other stuff in 9, but this was kind of the big impact that has kind of rippled through the ecosystem. And it turns out that Spring actually builds on a lot of Jakarta technologies. So if you look in the code in your Spring app, you will see a lot of these JavaX dependencies. So you have a lot of Jakarta stuff in your code, and you will be affected by this namespace change. And that's where Jakarta comes in when you do the migration from Spring Boot 2 to 3. Luckily, we've done a lot of this migration because we did it from 8 to 9. So that's where we can help Spring developers a little bit, because we've done this for a couple of years. And I'll just point to some of the specifications that are probably more relevant to Spring developers than others. And persistence is one of them, or you probably know it as JPA. And so that's Jakarta persistence. And Jakarta persistence, well, that's Hibernate. Hibernate is Jakarta persistence. And you're probably using Hibernate ORM in your Spring Boot applications. So if you do persistence in Spring, it's usually Hibernate. And that's Jakarta persistence. And what we did in the latest version of Jakarta persistence is actually we introduced UIDs as basic Java types. So now in their Spring applications, you can actually do like this, like we do in Jakarta, and use UIDs if you want, without any conversion back and forth. If you use it as primary keys like this, you can use the generation type and the ID, or you can just use a new UID and any field in your entities, and it'll be fine. The other one is bean validation. This is actually changing name now. For Jakarta 11, we're going to call it Jakarta validation. So we're removing the bean name from it. And if you use a Spring, you're probably using Hibernate Validator, which just comes with Spring. So if you do some validation on your entities or any classes in your Spring applications, you're probably using Hibernate Validator, which is Jakarta validation. The third one is maybe not that obvious because you don't use it directly, but that's servlet. And Spring Boot is all about servlets. And if you start a Spring Boot application, just download it and from the initializer and start it, it will use Tomcat. And you can configure it to use Jetty or Undertow or OpenLiberty or whatever else. But it's usually one of these, and these are servlet containers. So anything you do to interact with a servlet, that's Jakarta servlet. So I'll do a bit more code in this talk. So let's move into a demo. The first one is actually without any code. We just look at code. So that's the scenario where you're creating a new Spring app. You're going into starspring.io and generate a new app, and you don't choose the runnable jar. You choose the war, because you can do that in Spring as well, and Spring Boot. And because I have an old Tomcat in the basement and I want to deploy to that one, it could happen. So you have a Spring Boot 2 application and you want to deploy it on your own Tomcat 9. Will that work? No, it won't, because Tomcat 9 is on server. This is the old server. This is on Java namespace. So it will actually deploy it will say web app found, web app deployed, web app running, no warnings whatsoever. But it won't, when we start fiddling with it, nothing will happen because it won't run. Like it will deploy fine because it won't discover. It's scanning for Java X servlet. But you have a Jakarta .servlet in your applications. So it won't find your application. So it will deploy, but it won't run. So if you have some old Tomcats running and you want to do a Spring Boot app, you need to upgrade that Tomcats or whatever servers they're using. But I know that scenario isn't that usual these days. You use Spring Boot application and you run them as a jar, and that's what we're going to do in the remainder of this application or this time. So then we come to an upgrade and an old Spring Boot 2 application, or 1.4 in your case. So you have the Spring Boot 2 application and you want to upgrade it to Spring Boot 3. So what do we do then? Let's go and look at the code and see how we can get it done. So I have this application here. It's called Duke Boot, and it is it is a Spring Boot 2.7 application, and it has I generated with the Spring initializer. So it's just what I get from them. It's using validation and startup web, and I have a couple of dependencies here, and I use a in-memory database for persistence. Other than that, there's nothing here. It's a very simple application. Let's look at how it looks. So the Spring Boot application, you can see it start the boot Spring application run. So it's just a regular Spring Boot. And it has a REST controller that has a post method where I can post in a user. And when I get that user, I create an account for that user and I store it in the database. And I just print out some system of it. And then it has a get where I can list all the users, where it used the account repositories. So it's a very simple application. It has these two endpoints, but it stores in the database and retrieves them. The user is in the library, the Duke's library, which you remember from the POM file. I had a Duke lib and a Duke det. So the user stuff is in the Duke library, and the repository is in the Duke's dependencies. So I spread it out a little bit. But we won't look at that right now. What we want to do is to run it and verify that it works before we start the migration. So I'll just make this a little bigger. So I'll just Maven package. So I'm sure I have the latest version. And then I'll run it with the boot application. It starts fairly quickly. And then I can query the API with a HTTP get on the users. And you can see there are no users in the database, yes, because I just started. So if I do a post here, and I do a post with an email address duke@dukes.com, it will say 200, and we can look in the log here. It's account created with ID 1. So it seems to be working. I can now list the users, and you can see now I have one user in my database. If I input a invalid email, let's say it's only a Duke, it will say bad request. So it does some validation for me, and you can see it has some validation because the email wasn't correct, and it still only has the one I created. So that's the business logic. It validates that the email is correct before storing it in the database. So it works. So let's go and do the migration. The first thing I'm going to do is to open up here, and I'm feeling a little bald, so I'll go directly to 3.1.1. And I've heard from people who have done this in in real life, not in these kind of play applications, that it's smart to do 3.0 first and then 3.1. But because the Spring isn't very kind when it comes to versioning, because they can do breaking things in patches or minor or whatever. You never know exactly what you get. So do a 3.0 first and then 3.1. Could be a good idea, but I'll do the way over. And that's about it. So I've now changed it. So let's just look at the code, and here I have the compilation changes. So now I have the at valid annotation there doesn't compile because it expects it only has to be the Jakarta one. And there are several ways I can do this, several tools I can use for this, but for this one, since it's only one, I'll do it manually. So I'll change JavaX to Jakarta, and we were careful with that. We didn't change anything other than the package names in Jakarta inline, and that's specifically for this purpose, that you don't get other errors. So in 10, there may be things that are changed, and Spring has actually included some of the Jakarta 10 stuff, and they did that in between our RC releases 3.0. They upgraded to server 6, so they broke things between release candidates or patch releases, or I can't remember. So they support Jakarta 10 in some of the APIs, most of them actually now. So, but the idea was 9. So now I've done everything. The other class in my application works, so everything looks fine. Let's compile it and see how it goes. And I'll stop it, and I'll do the main package. Let's see. Oh, it failed. So something is not correctly here. It has some JPA stuff, some context, because I happen to have a test. If I didn't have this test to load the Spring context, I wouldn't have discovered this. But luckily, I have this small test class that just loads the application. That comes with the Spring initializer, and that helps us a little bit here. And now and the reason why we're coming to that is what we've done now is to take the namespace. We did the JavaX to Jakarta, and we could have used the IDE to help us with this. I did the manual thing. I'll do the IDE in the next step. The IDE actually just did Java to Jakarta namespace migration automatically for you in IntelliJ. So I'll show that refactoring afterwards. You can use Open Rewrite if you have a large code base. They have recipes for doing this. So what I did to kind of transform this application was to update the Spring version. I checked if I had any Jakarta versions. I didn't. So I would have updated them and fixed the imports. But it still didn't really work. And the reason is that our Spring app had some dependencies. And the Spring Boot application that we thought was this simple had this Duke dependency. And this Duke dependency had some repository things for the account class, right? So what I have to do is to take this Duke dependency, take it, check the source code for this one, and do the JavaX to Jakarta namespace for all of my dependencies as well. And then I can use a new version of it in my application. So let's do that. So the Duke dep has the account class, and you can see this is a Jakarta persistence entity, but it's Jakarta E8, so it has the JavaX persistence, and it's using Spring data. So it's just having an account repository. And let's see in the POM file, it is just a jar. It has Spring version 2.7.8, so let's upgrade this one to 3.1.1, so we're with the others. And it also has some Jakarta persistence and Jakarta validation dependencies. So these also needs to be updated. So let's do it to the Jakarta 10 versions. I think this one is 3.0.2 is actually working. So here I did upgrade the Spring version and the Jakarta version, so they kind of aligned. And now we can see that this one doesn't compile any longer. So what we can do here is to use the refactoring in IntelliJ, that is Java to Jakarta, which actually should have been Jakarta to Jakarta, or JavaX to, because it's Jakarta 8 to 9 actually. So I'll take the Duke dependency, and you'll also notice there that not everything JavaX is Jakarta. Right? You have something like the JavaX the SQL, the swing, the XML, and some transaction and some other stuff that is still in the JDK. So you cannot do a search and replace in your entire code base. But this one takes care of it and does it carefully and omits those that aren't affected by the netbase. So we do this and do the refactoring. You can see it changes everything in all the source codes. That's a convenient way of doing it. The next step I have to do is to release this dependency, and I'll release this as version 2.0. You can use a classifier for Jakarta or something to kind of keep the same version number if you want to, but I'll just bump the version number. And then I have it in my local Maven repositories. You can see the Duke folder has a version 1.0, so I'll just install the version 2.0. And now I have a version 2.0 in my Maven repository as well. So then I can in my Duke boot application, I can now up this dependency from 1.0 to 2.0. And when I've done that, I'll repackage the application and run it. And now it runs fine. So because now I've done the dependencies as well. So if I now query the users to see if there are no users in that list because I restarted it, I'll post the Duke.com. It's there. Right. Let's do the invalid Duke as well. Oh, I got a 200. That's interesting. Oh no, I have crap in the database. So how did that happen? Why did it go that way? So what I've done so far is up this string, this Jakarta dependencies, fixed imports, and then repeat for all the dependencies that I have the source code available for. Turns out that I have a dependency more, the Duke lib, and I don't have the source code for this one. So what I have is I have the Duke dependency, I have the Duke library, and what I need to do is to get this Duke dependency and the Duke library over to the new version. The problem here is that I have the source code for Duke dependency, but I don't have the source code for Duke lib. And how can this happen? Well, it could be something a library we created back in the 90s and submitted into Subversion, and nobody knows how to use Subversion anymore. And we don't have the source code, we lost it. It's an open source project that isn't maintained anymore. It's a library we bought. It could be any reason why you don't have the source code for this one. Of course, you can recompile it and try to re-engineer it, but it could be big stuff, it could be small stuff. The best way is obviously to find the source, either fork it from the open source or contribute back the change and do that. But in some case, you don't have the source anymore. So that's what this case is all about. Let's fix that. And this is about the Duke lib, and I don't have the source code to this one. It's here as my dependency, and if you remember, the user class comes from this one. And if we look at the user class, you can see this one has the add email annotation. So this is my code I have to figure out how to do somewhat. And how do we do that? Luckily, there is a tool for that. And that tool is called transformation. And there are two transformation tools out there. It's the Eclipse Transformer and it's the Apache Tomcat Migration Tool. These are specifically for this purpose. There are other ways of doing this. I think OpenRewrite can take bytecode as well. But what these does is to take the bytecode and translate the namespace for you in the bytecode. So you don't need the source. You can do it on bytecode level. So what I can do then is to take the Duke lib and transform it to a version 2.0 and use it in my app. Let's look at how that looks. So the Eclipse Transformer can be downloaded from, it can be used as a Maven plugin, so you can use it in your build system, or it can be downloaded as a runnable jar. It can be obtained from the Eclipse Transformer GitHub repository. So just Google the Eclipse Transformer and you will find it. What I've done here is that I've downloaded it to my local computer, and I have it put it in a. I think I had it.
Question: how come you haven't changed the JavaX import into Jakarta in this source file? It still says JavaX.
Yes, because it's a source file and I haven't transformed it yet. So that's what I'm going to do now. So what I'm going to do is to take the 1.0 from my Maven repository, copy it down here, and then do the transformation for it. So just copy the, you see I go to the M2 repository, I take the version 1.0, do clip jar, just copy it to this folder, so I have it here. And then I can run the transformer, and I've downloaded the transformer to a folder, and I just call it tools, and I have the transformer 050 jar. It's the latest version of that jar, and the input to this jar is the jar I'm going to transform. So if I do that, it will run transformation on it for me. I will now have a output duplicate jar. And if we look at these two and compare them, we can now take these two and compare the archives, and you'll see the only difference between them here is that the import has been changed, and this is in the bytecode in the jar file. So never touch the code. I don't need to see it. This is it does the transformation for me. And the next step I have to do after that is to make this jar available for me. So I have to install it in the Maven repository. And I can simply do that with install 5. So I just take the output Duke file and use the same group ID, same artifact ID, but a new version 2.0, and install it in my Maven repository. So I do it manually. Of course, I could do it to my local Nexus or whatever, but it's beyond this folder. So now I have it in a version 2.0 in my Maven repository. Yes.
It doesn't seem like there's any best practices on whether to bump the major version or to just use a classifier.
No, I don't think so.
This, which is frustrating.
Yes.
I go into various open source projects and it's hit or miss which they're using.
Yeah. So it would have been great if the community has agreed on some standard, but I don't think we're there. And yeah. So and this one is something I had in my company that I may not even know the license of this one. So it's probably not something I should put out there. So this would be something you would follow your internal company's policy for versioning stuff, and maybe keep it within the company. So the next step then is to start using this one. So I'll just bump the version to version 2. Reload the jar, and then I can rebuild my application and run it again. If I now do a Dukes.com, so it work, and I have one there. Let's do just the Duke, and now I get a battle request, and now the validation is back the way it's supposed to be. So these are the steps needed to fix stuff. So as for everybody else, the Spring dependencies and the Jakarta versions, if you have any fixed imports, you can use tools like IntelliJ, the refactoring stuff there, or OpenRewrite. Repeat for all the dependencies and transfer libraries if necessary, if you have any. Hopefully you don't, but this is where the tricky part is, because these libraries can have transitive libraries again. So you can have a lot of transitive stuff. So you have to kind of dig very deep before you nest your way back again. Yes.
Could the transformer be classes added to go check and see if there are any jars in your paths that might have that necessary, and so having to do that each iterative time and time?
So
it's easy to miss.
It is, yeah. So the transformer is in its current functionality that it doesn't do that, but it should be possible to write a tool that does it for you. Yeah, so it should be possible. It doesn't today.
And then another piece of feedback you might bring back to that team is, could that be added to SDK man so that we don't have to go find that jar?
The transformer, yeah, that would be cool. Yeah, I'll ask them. They're still on version 0.5, so I'm not sure how it is there, but probably the Maven plugin would be easier to use. But definitely,
if you're only doing it once, you don't
Yeah.
have to do it at each build.
No. Yeah, to have some.
The
Yes.
risk is, as your example really shows well, unless you've got really thorough testing, things could slip through.
Yeah. So these.
Without a good scan to find any
Yeah.
transitive dependencies in a Java example.
Yeah, so I didn't have any tests. That's why I get crap in the database. So if you have good tests, you will have discovered this. But yes, that's a problem. It will sneak in because the newer application servers, they don't get to whatever you're using underneath. They don't know about the Java X namespace anymore, so they won't discover it. It's just another class. So yeah, that's the sneaky stuff. That's where the challenge is. So I've added a couple of extra things that you may or may not need to think of. And that is if you have any properties in the application that are prefixed with JavaX. And this is probably related to Hibernate or other things that are implementations of Jakarta specifications. Because Hibernate has some caching settings you can use. And you probably can do that with Spring Boot properties in that file, but you may also have a caching strategy defined as javax.caching.strategy. And newer versions of Hibernate won't discover that. It has to be Jakarta caching strategy. Yes.
Do you know if IntelliJ takes care of that? Because it can see the properties.
It doesn't do the properties files.
Really?
The transformer from Tomcat does it. I don't think the Eclipse transformer, or there are some things the Eclipse transformer doesn't do, like the XML namespaces and stuff.
Yeah.
In a Spring app, if you do a transformation of a Jakarta app, you probably have some XML namespaces you have to fix. In a Spring app, you probably don't. If you have a web UI here that are using JSPs for some reason, then you would have to fix the namespaces of some of the deployment descriptions if you have a web XML or something. I don't think that's very usual in Spring apps.
Yeah.
You may also have some where you dynamically build some classes and fully qualified paths and just append JavaX something in front of it. And so if you have some dynamic stuff, it may be a migration step that you have to do. So before I go beyond Jakarta, do you want to show the UID stuff in persistent as well? We don't have time. Okay, so beyond Jakarta 10, and this is where it sort of is relevant because now you see how big an impact actually when we do stuff in Jakarta, how it impacts Spring applications. And there are stuff in Jakarta that will be picked up by Spring. So it pays. It may do you well to pay attention to what's going on in Jakarta, because when we come with a new persistent API, that will be picked up by Hibernate, and then you will be using it. So paying attention to what's going on is you know what's coming in the next version of Spring. So Jakarta 11 is scheduled in around summer next year. Hopefully, maybe after summer, but we're hoping for before summer. And that's Jakarta 11. We are trying to establish a release cadence you can rely on. And the release cadence we're striving after is to have a release of Jakarta EE 6 to 9 months after a LTS release of Java. So when 21 comes out, 6 to 9 months after is around H1. And that's what we're trying. So we will have a 2-year release cadence of Jakarta. That's what the steering committee at least wants us to do. We are adding Spring Jakarta data, and it's a complete rip-off more or less of Spring data. And it's open source, is allowed. So we're standardizing the repository pattern for data access. So if you, for some reason, figure out that Spring is too complicated, it has too many dependencies, too many security vulnerabilities in your dependencies, and want to go to an application server where everything is kind of proven to work together and it's built by IBM or whatever.
Is that built on top of JPA?
This will be possible to build on top of JPA. It will be independent of the underlying mechanism, but JPA will be the first one that it will. It won't require JPA, but JPA will support it.
Oh.
So it will be exactly the same as Spring Data, the stuff. We have a Jakarta NoSQL that standardizes integration with NoSQL databases. This one will not be a part of the platform. It's a standalone specification that will live on its own and maybe be picked up in Jakarta 12 or later. But right now, we don't feel it's mature enough to be part of the platform. We also have started a Jakarta RPC, which will standardize gRPC within Jakarta. This one also hasn't come far enough to be a candidate for 11, so it will be a standalone for this release. For Jakarta 11, we will we will compile those sources to Java 21. So in order to use Jakarta 11, you will have to be on 21. We will run the TCKs on 21 only and require that for the runtimes. So we're bumping the Java level to the latest version to stay on top of things. And that means that we will fully incorporate records, for example, in all the validation and Jakarta validation will support records properly. We will also be picking up virtual threads. So we will have some simple APIs to make it possible to enable, to have some application kind of a little bit tickle with the virtual threads for performance. So we're doing that in Jakarta concurrency. So we will be on the latest version when Jakarta 11 comes out. To sum up, Jakarta 10, lots of good stuff, lots of new stuff. Some of them are more relevant than others to Spring developers. We're looking at persistence validation, and servlet is also a specification that is Springlet is built up of. We have the new Jakarta core profile, which is targeting a smaller runtime. So if you want kind of a small microservice and even combine it to native and run it as a serverless thing, implementations that implement the only core profile are suitable for that. We're kind of the target applications for this were such as Helidon, Quarkus, Micronaut, that kind of smaller frameworks. None of them has certified yet, so that's kind of what it's made for. I hope this gave you a little bit insight in why Jakarta E is relevant to Spring and how Spring builds on top of Jakarta and it pays a little bit to pay attention to what's going on in Jakarta and the JavaX to Jakarta namespace is something we had to do, and I'm not sorry about it actually, because I think it's a good split. We now see what Jakarta is, and it was a healthy thing for the ecosystem to actually be able to go through this. And when we see Spring had to go through this and did it in their previous version now, we won't do it again. But that's it's not necessarily a bad thing. And a little bit of hassle for developers, but you can get through it. These are, you can get most of the stuff done. The tools, Open Rewrite, Transformer, if you have to, or the utility stuff are out there. There are people blogging about it, writing about it, talking about it. So it should be possible to get help. I'm sure consulting companies are happy to help other people with struggling, so it's money out there to do this. If you want to know more about Jakarta E, you can go to jakarta.de, and if you want to do just try out Jakarta E, we have a starter like the initial Silver Spring. So you go to start Jakarta.de and just select some things and generate and get a zip file and run it. I do the weekly hashtag Jakarta E, and I also blog from all the events on that. So if you want to read about this event, you go to my blog. Demo code is out there. If you want to learn about Jakarta E, I have a course on LinkedIn. So if you have a LinkedIn learning subscription, you can do this course. If you don't have a LinkedIn subscription, this is where you contact me on LinkedIn, because I can give you a free version.
Actually, anybody in Columbus who has a library card has a free subscription.
Yeah, so if you have a free subscription, use that one because then I get paid.